So as we discussed that we finished lexical analysis part, and we are starting syntax and semantic analysis. So syntax and semantic analysis is a very crucial phase into a compilers and overall design of the compilers, because this phase is responsible for checking the syntaxes and the semantics that are associated with the statement that are being written by the user. So in particularly into the program. So we have to go for the discussion on this particular topic now. Now prerequisite for this is like for dealing with syntax and semantic, that is parsing phase, we need a support of lexical analysis. By what it is required, that whenever the syntax and semantic analysis requires a symbol, the lexical analyzer will act as a coroutine and generates the symbol and will supply the symbol to the parsing phase. Okay, so what we have understood so far is as far as syntax analysis, that is parser, is concerned, the role of parser in compilation model, where the source program is being provided to a lexical analyzer generates the token and provided to the parser. Now what parser does with that particular token generated symbol, it formulates the parse tree, and then it formulates the parse tree, check whether that parse tree is appropriate or not. Then for doing so, the parser has to go through the two different approaches. They are called as top-down approach and bottom-up approach. Now, in case of a top-down approach, these methods are building a parse tree from top, that is root, to the leaves, and from bottom-up means from it is building a tree from leaf to the root. So it starts, in case of bottom-up methods, it starts from leaves and work there up to the roots. So bottom-up and top-down, this particular approach is something like this. In case of top-down, the approach will be like this. In case of top-down, and in case of bottom-up, the approach will be like this. So this is bottom-up. Okay, so means what? Say for example, you have an expression. In simple case, you have expression C equals to A plus B. So in this case, we know that this has any expression has two sides. This is called as LHS and this is called as RHS. So means if we write LHS RHS. So in short, this representation is called a tree. Okay, and if I start this exploring tree in this particular way, then it is top-down approach. And if I start exploring this particular tree in this particular way, this is bottom-up. So this is top-down, and this is bottom-up. Okay, so further we can represent this. Okay, what is this LHS here is, we can say C. So C is equals to RHS. Here what we are going to have is the representation something like this, A and B. So A plus B, this is going to be assigned to the C. So this is how it is going to be. Okay, so this we need to understand, and the key terms that are here is this LHS, RHS. Okay, so syntactically we are going to check whether the things are correct or not. So for this, on the basis of this, we are going to have a parse tree. Okay, so now as far as the errors are concerned, right? We understand that with every phase, we are exposed with errors. Exposed with errors. So, for examples, if the type is not defined, Okay, so there is a type definition error. Okay, so by type I means like you can say define types. Type it can be primitive or a non-primitive. It can be primitive or non-primitive. So by primitive and non-primitive, you are already exposed with this. Okay, but so you must have to have a defined type. So this type of as error. Okay, or if like symbol is missing. Symbol is missing. Okay, means for example, if your expression is equal is C plus. Okay, so if the expression is C plus, that means what something is missing here. So it means that if I draw a tree, then this tree will be something like A, and this is question mark. So symbol is missing here. So in this case, like this is going to happen. So, but if you look at the lexical analysis, what are those errors, right? If you look at the lexical analysis, what are those errors? Errors include misspellings of what identifier. Okay, but let's see if I write identifier as say if I define say integer my age. If I define a variable as integer my age as 0, and somewhere in the program script if you write variable as my age, so ultimately this is new symbol. So this is due to because like representation is not proper. Okay, so the identifier goes into this particular way. Keywords like you are expecting int and you are writing something different, right? So if the keyword is an issue, then it is like that. Or if operators are not proper, then again the things are lexical. It is included into lexical errors. Now, if you look at syntactic errors, if you look at syntactic errors particularly looked with semicolons in case, right? Errors include misplaced semicolon or extra or missing brackets, appearance of the case statement without enclosing with switch, or any syntaxes. So particularly like this can be a very good example for a syntactic error. Semantic errors usually deals with mismatches between the operator and operands. Okay, so this is important. Logical errors, anything can be incorrect reasoning on the part of the program, and seriously these errors are very difficult to handle. These errors are really very difficult to handle. So what is corrected, on the contrary, if you ask me what is corrected, so I can tell you like syntax, and what cannot, then that is logic. Okay, so what cannot be corrected is logic cannot be corrected, but syntax can be corrected. So this is really very important as far as the errors are being considered. And these errors are progressive things. So if you got an error at one particular phase, it will be reflected everywhere. Okay, so doesn't mean that the lexical error will not have any impact on the syntactical error or likewise. Everywhere it is being reflected. Okay, so this is you need to understand. Okay, so as we understand that in previous lexical analysis itself, we have seen that what are the important terms for language. So I said important terms as far as language will be set of alphabets, or we can say these are symbols. And the second important term for language is grammar. Okay, and we define grammar as rule. Okay, and if at all we are going to generate certain thing for, or writing some expression, or generating some symbolic structure, or generating some word, then it must follow the rule. So in general, this rule defines the system. Rules always define the systematic representation. Rules define uh, systematic, we can say, representation. Okay. Say for example, if I wanted to write an expression, so expression has two sides, right? So this is LHS, and then you have a RHS. Okay, so expression has two sides here. So this must be an identifier, then this must be an identifier, then operator, then identifier. So what it means that, okay, what it means that if at all you wanted to write an operator, then the operator should be in between the identifier. If this is a rule of writing a simple expression, then this can also be represented into a grammatical form, right? How to represent this? What are the important aspects that we will learn into either this session or into the next session. Okay, but the important term which is coming here is called as context-free grammar. Okay, so context-free grammar, this context-free grammar has four components, or we can say CFG is defined by four tuple structure. Okay, the way like FA defined by 5-tuple structure, your context-free grammar CFG is defined by 4-tuple structure. Okay, so what is that? It contains first part as terminal symbol, which we have already defined. What are terminal symbol? Terminal symbols are particularly represented by lowercase letters, and they are refers to the tokens. The terminal symbols are the elementary symbol for a language defined by the grammar. So terminal symbol are usually the symbols that are referred into small case letter, and most important characteristic is that they cannot be substituted, right? Means they cannot be extended, rather they can be substituted, but they cannot be extended. Okay, so non-terminal symbol, so usually this terminal symbol is referred as T, and non-terminal is referred as NT. Okay, so non-terminals are referred as NT. They are like the way terminal symbol called token, non-terminal called as syntactic variables. Okay, so usually non-terminals are represented into bold-face letters, so they are represented in bold-face. They must be substituted. They can be substituted, right? This is important. They must be substituted. So you can substitute this non-terminals here. Okay, and the next important thing is the production. Okay, so production is what? Production here refers to the rule, right? So in short, we can say that production refers to rule. Okay, and this rule is composed by using terminal and non-terminal. So this can be written as non-terminal is producing either a terminal or a non-terminal. Okay, so this is the rule. Okay, so the production is where each production consists of a non-terminal. It's called as head, and which is at the left side. So here, if I say this is the production, then this terminal is called as head, and this head is at left side. Okay, so means here LHS refers to the start always. Okay, so start symbol is and the left hand side and is of type non-terminal. Okay, so this is important, and the next important thing is a start